This should be somewhat similar to the last question. I picked questions close to the questions that you were asked so that they should somewhat be similar. But more than that, I want you to notice how similar solving them also is. I've solved two completely different problems, basically using the same exact reasoning. So I'll show you that we're going to do the exact same thing here. Let's read it. Strain is a measure of the deformation of an object. It can be measured using a foil strain gauge shown in figure P1.36. So that is a foil strain gauge. Okay. Do we care anything about it? Not really, unless we're being told to build one. But we're given that this is what we have, and this is some data underneath it that goes with it. Okay, so the strain being measured, epsilon, and resistance of the sensor satisfying the linear equation. There's our equation. R equals R sub 0 plus R sub 0 times S sub epsilon times epsilon, where, again, it's telling us R sub 0 is the initial resistance, and they're telling us it's measured in ohms of the sensor with no strain, and S sub E is the gauge factor. And they're telling us that the gauge factor is a multiplier with no units. Well, there's something important about the fact that this is a multiplier, a gauge factor, and it has no units. Because what it's really telling me is that that's my constant. Okay. Using the given data, find the equation of the line. Oh, back to equation of the line. For the sensor's resistance R as a function of the strain epsilon. So again, we have R as a function of epsilon. So now we know what our two variables are. Everything else are constants that we have to determine. And you'll notice it says determine the value of the gauge factor S sub E, which is going to be our constant, and the initial resistance R sub 0. Okay, so again, we have a linear equation. R equals R sub 0 plus R sub 0 S sub epsilon times epsilon. I'm just going to rewrite this as R sub 0 S sub epsilon times epsilon plus R sub 0. Now, this whole thing right here is the number that's in front of my epsilon, isn't it? And since that's the number that's in front of my epsilon, that is the slope. So the slope is actually the initial R times S sub epsilon. A little bit of arithmetic if you don't want to have to put out your calculator every time you do anything. If I move this decimal point 2 places to the right, then that becomes 1. So I can move this decimal 2 times to the right, and this becomes 200. Okay, so now we know our slope. So we can rewrite our equation as R equals 200 times epsilon plus R sub 0. Now, the really nice thing about this, the data that they gave us, is they actually gave us R sub 0. And I don't know if you guys can see where R sub 0 is, but remember that R sub 0 is the same as the y-intercept. And whenever you want to find the y-intercept, you have to set x equal to 0. Here, our x is epsilon, and they actually give us the point when epsilon equals 0, which gives us my initial condition for R, which also is the same as giving me my my y-intercept. So And I could just plug in 0 for epsilon, and you'll see that R equals R0 and R equals 100, right? So if we plug in those numbers there, I guess I should do it instead of explain it. I have 100 equals 200 times 0 plus R sub 0, which means that R sub 0 is equal to 100. So we know that R sub 0 is equal to 100, and we know that M is equal to 200. So now let's answer all the questions. And I'm going to answer all the questions actually up here. Answers. Okay, so find the equation of the line for the sensor's resistance, R, as a function of S. Okay, well, we did find that. R is equal to 200 times epsilon plus 100. Okay, so we answered that question. And determine the values for the gauge factor S sub epsilon and R sub 0. Well, we know R sub 0 is 100. We already talked about that. And we know R sub 0 times S sub epsilon, which is our slope. But if we just want S sub epsilon, we can divide our 200 by our R sub 0 here. So if I know that 200 is equal to R sub 0 times S sub epsilon, and R sub 0 is equal to 100, then we can see that S sub epsilon is equal to 2. And that answers everything in part A. And all the questions that you have for part B are basically just graphing it. And graphing it is not, don't make it hard. You have 2 points. So you have 2 points, and to make a line, all you need is 2 points. I'll graph it for you. So it's going up from 100 to 102. So I think what I'll do is I'll say this is 100, and then this will be 101, and this will be 102, because otherwise it's going to be too hard to see the difference in the points. And it's going from 0 to 0.01, so there's 0, and we'll make this 0.01, 0.02, and so on. Okay, so I have my 2 points, 0, 100, and 0.1, 102. Now, this is our epsilon line, because that's our independent variable, and this is R, because that's our dependent variable. And I have I'll use the ruler. I have 2 dots. So if I have 2 dots, I can just connect them, and I have a line. So there's my line. Clearly indicate R sub 0 on the graph. Well, R sub 0 is always your initial condition when your independent variable equals 0. So this is R sub 0. And that's basically it. That's the graph of R. I will post a video next week. Thank you very much for watching. Bye-bye.